Hey everyone, welcome back. In this presentation, we're gonna briefly talk about VHDL versus Verilog. First off, both of them are hardware description languages that we use to describe hardware concurrency parallelism. Here's a table with a summary of some of the main similarities and differences between the two. VHDL is a strongly typed language as opposed to Verilog that is weakly typed, meaning that it might be more flexible when it comes to type conversions, but it will be more error prone. Verilog, being more similar to a C programming language, will lead to more concise and less code, as opposed to VHDL that is not so much like C and will result into a more verbose, wordy code, but I think it will be in the long run easier to understand because many aspects and details will not be hidden. Verilog might be a bit easier to learn at least at the beginning, as opposed to VHDL that may appear to have a steeper learning curve. VHDL has the advantage of being a little bit more deterministic as opposed to Verilog. Finally, I think that VHDL is more popular in academia and educational setups and Europe, while Verilog appears to be more popular and talked about in industry and in the United States. Some, don't quote me on this one, say online that VHDL may be more used in military applications. My discussion in this presentation is based on a project that I did a while back, which was to take an existing Verilog project, which is essentially a driver, an HDMI driver that one could integrate in any project that would involve an HDMI DVI monitor to allow your application, your project to display images. So I took that. I'll show you later on side by side the two files, and converted that from Verilog to VHDL as an exercise to learn the similarities and differences between Verilog and VHDL. This VHDL source code at the top level, only converted into VHDL, is available at the links provided here. I did verify it on two different displays and monitors. It works. So if you have a project where you want to integrate an HDMI driver in VHDL at the top level, this might be a good option for you. So it is within this context of translating from Verilog to VHDL that I'm gonna show you on the next couple of slides, side by side, some of the things that you would see in VHDL or in Verilog. For example, in VHDL, we work with what's called entities, and we have here, for instance, an entity declaration, which corresponds to the module in Verilog that looks as shown on the right hand side. So you see already that VHDL involves a little bit more code, it is more wordy, but from both of this you could make sense what this is about. The module, the name and certain inputs and outputs. We have wires in Verilog and as ports and signals in VHDL. So from Verilog going into VHDL or vice versa should not be a problem. I was mentioning wires versus signals. In VHDL, we work with what's called signals, as you see in these examples here on the left hand side, of certain types like standard logic. In Verilog, we work with, I think, more meaningful terminology called wire. So a wire reset, a signal reset of standard logic type in VHDL. If you work with buses, with vectors, you would have them declared like so here in Verilog, as opposed to VHDL, where you would have, for instance, a standard logic vector on 4 bits. In terms of instantiating and creating instances of different entities in VHDL, this is how you would do. We use what's called port map to instantiate an entity called iBuffer, to which we give a certain optional name and make the connections I and O to the local signals where we want to instantiate this, to the local signals sys underscore clock and sys clock. In the world of Verilog, you would do that component or module instantiation as shown over here, and you could see it's quite understandable and easy to make sense out of it as well. And you'll see here a couple of more examples of such port maps or instantiations. When it comes to processes in VHDL, to describe, for instance, a certain functionality that would happen on the rising edge of a certain clock signal, this is how you would write code in VHDL, and this is the counterpart that you would have in Verilog, or you would use the construct always. You see here on the lower side a more complex example where in VHDL you would have a process with an if statement inside which you would have a case statement that would have a couple of different branches, like so. When SW underscore VGA, then do these two signal assignments. In the world of Verilog, that case statement becomes this case statement where you would have this branch with the two wire assignments as shown over here. So when I converted from this to this, I replaced these two wire assignments with these two signal assignments as shown over here, with the comments of what that corresponds to from the original code. Finally, the assignment in the world of VHDL, signal assignments would be done using this operator, and these are some examples. You would assign to a certain signal another signal. You would assign to this signal the concatenation of a couple of different signals to create the number of bits necessary for that. Here, the counterpart in the world of Verilog would be as shown on the right hand side, and it's pretty self-explanatory what these assignments are all about. The way you would end an architecture description in VHDL would be saying and the name of that architecture, and in the world of Verilog you would just say and module. Finally, if it were for us to summarize some of the main takeaways, both VHDL and Verilog are hardware description languages. They are more or less equally popular, and both, more importantly, supported by virtually all major electronic design automation vendors out there. You take any EDA CAD tool, they will be able to understand and work with source files in VHDL and Verilog, or a mix of those. You can create designs that mix and match IPs written in VHDL, Verilog, and create projects that use both. A mix of those, no problem. VHDL may be a little bit more wordy, more verbose, but I think it is generally easier to read later on, or have your code read by other developers, other engineers later on. And if you know one, it shouldn't be too difficult to pick up and learn another one. In my experience, the best way to do that is start with an example in Verilog or in VHDL and port it, translate that functionality into the other one, and in this way go through the experience of seeing and understanding all the concepts from one world and another. Um, as far as I know, in industry, you will most likely need to learn and be familiar with both of them, because you will very likely deal with IPs, vendors, customers, etc. that use both for sure. Last but not least, I feel, based on what I read and I understand reading online, that there is a trend of moving more and more towards system Verilog, a later version of Verilog as a standard. So that's another thing that is happening. P.S. I forgot to show you side by side the VHDL and Verilog files that I was talking about. I had translated this file, VTC underscore demo, that I have on the right hand side, written in Verilog, to VHDL that you see here on the left hand side. So you can see here the entity declaration that I have written in VHDL, with then the architecture that starts here and goes till the end of the file. The module in Verilog starts here, and you would see some of the counterparts as I translated them from Verilog to VHDL side by side, like so. I'm not gonna go through all of this. I just wanted to browse quickly through both of them, the original on the right hand side in the Verilog, and the translated to VHDL on the left hand side, for you to get an idea about how that looks in terms of the number of lines and how wordy these files might appear as you look at them. So here is on the right hand side the original Verilog code. As you can see, it's quite long. There are about let's see, 674 lines of code in Verilog, in VHDL. It is a little bit more wordy with all of this standard logic vectors and comments that I had to add, but it's not terribly wordy or bad. I actually like it more. It's more readable, more self-explanatory. And if you look at the total number of lines of code, I don't really have more lines of code. It's more or less in the same ballpark as you can see here at the end. Just a few more lines of code, but I had more comments added here and there as well. So that's all.